Hello everyone. I'm now going to work on part 2 of the solutions of project 2. This is the free response section, and before I go into the questions, I just want to remind you that for the free response questions, please make sure you show all the steps while you work through the answer, because every step has points assigned to it. So if you miss a step, then you will lose the points for that step. All right. Now, the first question here is on quadratic function. The function given to us is x squared plus 6x plus 3, and then there are some follow-up questions pertaining to that function. Part A says write the equation in vertex form by completing the square. So just to remind you what the vertex form is, it's of this type: A times x minus h whole squared plus k. This is the vertex form of a quadratic function or a quadratic equation. Now, our book, for some reason, refers to this as the standard form, but this is really the vertex form because it gives us information on the vertex of the function, of the graph of this function. So what is completing the square? Now, let me just also mention that completing the square is not a topic of this course, really. It is something that you are already expected to know from a previous course. However, I'm going to go through the steps of the process anyway, in case you need a review. What does completing the square means? Now, we have seen binomials in whole squared form, right? So a plus b, the whole binomial squared, is expanded using this form. There's a formula to the a plus b whole squared, which is a squared plus 2ab plus b squared. Likewise, a minus b whole squared is a squared minus 2ab plus b squared. So the function given to us is x squared plus 6x plus 3. We have to put it in this vertex form given here. All right. So that means we have to force the standard form of the equation into this form, a whole squared form. There has to be a whole squared in the new form, all right, in the vertex form by completing the square. So let's go through it step by step. The function given to us is x squared plus 6x plus 3. So take the function, make the other side equal to 0. In the next step, just see if your leading coefficient, which is a, leading coefficient would be the coefficient of the squared term, right? Now, the squared term must have a coefficient of 1, or as it is in this case. If it is not 1, then you will need to divide all the terms of the function or equation by a, by whatever the leading term value is. So here I think we are good because the coefficient of the first term is a 1. All right, so we don't have to go through that division process for this particular question. In the next step, what we must do is take the constant term and move it to the other side. So I have x squared plus 6x. Keep the x squared plus 6x on the left-hand side. Move the plus 3 over to the other side, and it becomes negative 3 when we do that. And then what I'm going to do is I'm going to draw a box with a square on both sides of the equation. Okay, a box squared on the left-hand side, a box squared. Whatever you do on one side of the equation, you have to do exactly the same thing on the other side, right? If you have a box squared on the left-hand side, you better have a box squared on the right-hand side as well. Now we have to put a value in the box, all right? What value should we put there? Take the middle coefficient, in this case 6. So we take the middle coefficient, which is also b, right? Take the middle coefficient. So let me write that. Middle coefficient divided by 2 goes inside the box, all right? And write in the box on both sides. So we have 6 divided by 2 is a 3. So I'm going to write 3, and it's a plus 3, right? Because it's a plus 6 divided by 2. So it's going to be a 3 inside the box. Write the same value on the other side as well in the box. Okay, so now we have x squared plus 6x plus 3 squared, which is a 9, all right, which is of this form here, all right, which is of this form here. So now in the next step, I'm going to convert this and write it in the whole squared, a plus b whole squared form. How do we do that? Just put a bracket. All right, let's put a round bracket. And then for the first term, just take x without the square. We are going to put the square outside the brackets. All right, so inside the brackets, just write x and then a plus, and then whatever is inside the box. All right, plus 3. So x plus 3 squared, or x plus 3 whole squared. And let me just rewrite this. X plus 3 whole squared is the whole squared form of x squared plus 6x plus 3 squared, which is a 9. On the other side, we have to simplify. So we have a minus 3 plus 3 squared is a 9. So we have x plus 3 whole squared equals positive 6. And now in the final step, just bring the 6 over to the other side and make the right hand side equal to 0, or replace it with f of x. So I'm going to write this. I'm going to move the 6 over to the other side, and it's going to be x plus 3 whole squared minus 6 equals f of x. Just replace the 0 on the other side by f of x. So now we have the equation completed in the vertex form, x plus 3 whole squared minus 6. Okay, so let me write that here in a box like the question says. The vertex form is x plus 3 whole squared minus 6 equals f of x. Part B of the question says state the vertex of the equation. So now that we have got our function in the vertex form, it's very easy to pick the values of h and k, which are the coordinates of the vertex, and state the vertex as an ordered pair. So what I'm going to do is I'm going to align this particular function that we just found, that we just put in the vertex form, in the generic form. We are going to align it to the x minus h whole squared plus k form, and then pick the correct values of h and k. So the form is a times x minus h whole squared plus k. All right, that's the generic form. So let's align x plus 3 whole squared minus 6 to this form. So 1 is what a is, right? The coefficient outside the brackets of the whole squared is a 1. So a is 1, and then we have an x, and then we have a minus. So let's write the minus of the form. And then h, once we pulled out the minus from the plus, we are left with minus 3, and that's going to be our value of h. Then the square, all right, so h is going to have a value of minus 3. Then the form has a plus, so let's put the plus, and the rest of it is minus 6, and that's going to be the value of k. So we got our values of h and k, and that is going to be the vertex. So I'm going to write here the vertex is stated as h comma k, which is -3 comma -6. Now we learned another way of finding the vertex of a parabola, and that is using the formula of minus b over 2a. So let me work this through using the formula method for h and k, and then we see if it matches with what we found from the vertex form. So the formula to find a is minus b over 2a. Minus b over 2a. We have to find the values of b and a and plug it in to this formula, and we'll get our answer for h. So here we have a equals 1, right? A is the coefficient of the first term, so that's 1. B is plus 6, the coefficient of the second term, and c is the last constant term, which is plus 3. So here in the minus b over 2a form, we have a minus, and then b is positive 6, and then in the bottom we have 2 times a is a 1. So 2 times 1, which is minus 6 over 2, which is minus 3. So we got a value of minus 3 for h, which matches exactly with what we got above here, right, from the vertex form. Now we have to find k. What is k? K is f of h, all right, or f of negative b over 2a. So that's what k is. K equals f of h. So whatever we found for h, whatever value we found for h, we need to plug that in to the function, into the function, and evaluate it. So f of h means f of -3. So let's plug in -3 into wherever there is an x. So we'll have -3 whole squared, and then we had a plus 6x. Just a second, let me just rewrite this here. -3 whole squared plus 6 times -3 plus 3. All right, so -3 whole squared is a 9. 6 times -3 is -18, and then plus 3. All right, plus 3. So let's simplify this further. 9 minus 18 is -9, plus 3 is -6. So h is -3 and k is -6, and that's exactly what we got here from the vertex form. All right, so there are two ways you can find the vertex of a parabola. Either you use the complete the square method and put the function in the whole squared form and then extract the values of h and k from the form, or you can use the minus b over 2a for h, and then for k you just evaluate the function by plugging in whatever value we found for h and evaluating the function. All right, so do whatever the question asks you to. Now part C says state the x-intercepts. So we have to find the x-intercepts of the function. Now remember, at the x-intercept, the y value is equal to 0. So the way to find the x-intercept is to solve for x in the function given by making f of x equal to 0. So our function is x squared plus 6x plus 3 equal to 0. We are going to make the other side, we are going to replace f of x with 0, and now we are going to solve for x. And we should come up with two values, two solutions for x, and those are going to be the x-intercepts of the function. The first thing to look for is to see if we can factor the trinomial and then solve for x by using the zero factor property. Here, there's no way we can find factors of 3 which will add up to a 6. So this cannot be solved using the factoring method. We have to use the quadratic formula in order to solve this. So let me write down the quadratic formula here. It's x equals minus b plus minus square root over b squared minus 4ac over the whole thing over 2a. So we have to apply this formula and come up with the values of x. Now a, b, and c are the coefficients of the different terms of this function. So let's list the coefficient values and then we can plug them into the formula. So a, which is the leading coefficient, that is the coefficient of the first term, is a positive 1. B is also a positive 6, the second coefficient, and C, the constant term, is 3. So we have A, B, and C, all are positive values. Now we just plug them into the formula. So we have minus b, so minus 6, plus minus, then square root, b squared is 6 squared, minus 4 times a is 1, and c is positive 3. All right, so that completes the numerator. In the denominator, we have 2 times a, so 2 times 1. Okay, and now we have to just do the calculation of this expression. Let's continue. We have minus 6. We have to do the square root first. All right, so minus 6 plus minus square root over, let's see what we have under the radical sign. 6 squared is 36, minus 4 times 1, 4 times 3 is 12. So minus 12 over 2. Okay, so let's keep going. Minus 6 plus minus square root over 24. 36 minus 12 is 24 over 2. Okay, so we have to keep simplifying this further, okay, to its lowest term. So let's continue here. We have minus 6 plus minus, now square root over 24. How can we simplify that? We have to go back to our intermediate algebra radical lesson and try to recall how we simplified a radical expression. So we have square root over 24. 24 is not a perfect square, right? So we cannot take its square root as is. We have to factor 24 so that we can get a perfect square out of 24. Is there a perfect square in 24? It's 4 times 6, right? 4 is a perfect square. 4 times 6. And then we distribute the radical to 4 multiplied by square root over 6. So square root over 4 times square root over 6 is 2 times square root over 6. All right. So square root over 24, when simplified, we get 2 times square root over 6. So I'm going to write here 2 times square root over 6 divided by 2. Now, we have to keep simplifying. We are not done yet. All right. So let's see how we can simplify this. 2 is a common denominator. So it has to be distributed to both terms in the numerator. So I'm going to write it as minus 6 over 2 and then plus minus 2 times square root over 6 over 2. So here we see minus 6 divided by 2 is negative 3. So we have negative 3 plus minus 2 times square root over 6 divided by 2. The 2 divide and we are left with square root over 6. So we have two solutions. Although this looks like a single solution, but it's actually two solutions. We have to write it as minus 3 minus square root over 6 and minus 3 plus square root over 6. Okay, so we have two solutions for x equals, and those are going to be the x-intercepts of the graph. So let me write it separately. So we have it x equals minus 3 minus square root over 6 is one solution, or we can have x equals, just a second, x equals minus 3 plus square root over 6. Okay, so we found our x-intercepts. We got our vertex h comma k. This is our vertex. These are the x-intercepts. Now we have to find the y-intercept. Finding the y-intercept is pretty straightforward. Remember, at the y-axis, the x value is going to be a 0, correct? Y-intercept means the point at which the graph is going to cross or touch the y-axis, correct? That's what y-intercept means. And at the y-axis, x equal to 0. So the way we find the y-intercept is we make x equal to 0, all right, f of 0, and evaluate the function, replacing all the x values with 0. So we have 0 squared plus 6 times 0 plus 3. So we'll have 0 plus 0 plus 3 equal to 3. So the y-intercept is going to be at 0 comma 3. So y-intercept is at 0 comma positive 3. All right. So now that we have found the vertex, the x-intercepts, and the y-intercept of the function, I think I'm going to go ahead and sketch the graph and then go on to answering parts E and F, because it'll be easier for us to answer those two questions if we have an idea of what the graph looks like. All right, so I'm going to take out my pen here and draw an x and y axis, and then just scale it along the x-axis 1, 2, 3, 4, 5, and along the negative x-axis -1, -2. Let's just a second, it's not properly scaled. So let's make this -2, -3, -4, and -5, and let's make one more here, notch, -6. And along the along the y-axis, it's 1, 2, 3, 4, 5, and then some negative values along the negative y-axis. All right. Okay, so now let's see. First, we have the vertex. Okay, the vertex is located at -3, -6. So let's plot that. Now I have to extend the y-axis a little more to show -6. All right. So -3, -6 is somewhere here. So I'm going to put a point here. This is -3, -6, and that's where the vertex is going to be. Then x-intercepts. Now again, when we state the intercepts, we should actually put it in ordered pair. All right, so just x equals -3 minus square root over 6 and plus square root over 6 is not adequate. We should really show both the x and y coordinates. So that's what I'm going to do here. Let me rewrite this. The x-intercept is, one of them is at -3 minus square root over 6, 0, and the other one is -3 plus square root over 6, 0. All right, that's the proper form of writing the x-intercept as an ordered pair. Okay, so now going back to the graph, we have the vertex plotted. Now we have to plot our x-intercepts. All right, so we have to pull up our calculator and see what -3 minus square root over 6 calculates to. So let me do that. Okay, -3 minus, I have to redo this. It's -3 minus square root over 6 is -5.449. So I'll just round it up to -5.5. All right, so let's go back. So it's negative, this one, just a second. Okay, so -3 minus square root over 6 was -5.5 rounded up. So -5.5 will be somewhere here. All right, roughly here. So that's one of the intercepts. The other one, this one is -5.5. Let me write that. -5.5 for the first one. And the other one, -3 plus square root over 6. Let's run it through the calculator again. -3 plus square root over 6 is -0.55. So -0.6. So let's go back. This would be -0.6. So -0.6 would be -0.6 somewhere here between 0 and -1. All right, so I'm going to mark it here. Okay, so we plotted our x-intercept. Now the y-intercept is at 0, 3. That means it's going to intersect the y-axis over here at 0, 3. So now that we have these many points, let's just connect them with a smooth round curve and we will get our parabola of the function. So let me use this here. So let's connect. Okay, another x-intercept. Have it pass through 0, 3. All right. And then extend the two ends going up. All right, let's make that. All right, so let's observe the graph. Okay, it says part E. In part E, it says give the equation of the parabola's axis of symmetry. Now, axis of symmetry is the vertical line along which the graph is symmetrical. All right. So that's x equals -3. Okay. So the axis of symmetry for a parabolic function is x equals a certain value, in this case -3. So negative, it's always the h value of the vertex. All right, it's always the h coordinate of the vertex. So that's the equation of the parabola's axis of symmetry. And then for f, it says state the intervals on which f is decreasing. Okay, so what is that? You see over here, the graph is decreasing up to this point, that is the vertex, and then it turns around and increases. Then it becomes an increasing function. So it decreases between which x values? All right, it decreases between which x values? Now, on the other end over here, we see that this goes to infinity. So, -infinity, all right, the interval, let's put it like this. Okay, so the graph is decreasing from -infinity to -3. After that, it starts increasing. The function starts increasing. So the way we are going to write that is -infinity, always round brackets next to -infinity or positive infinity, comma, -3. Okay. We'll work on question number 2 now, which is a function of a higher order polynomial. It says f of x equals x cubed plus 8x squared plus 11x minus 20. So we have to work on this function and answer the questions below. Part A says use the leading coefficient test to determine the graph's end behavior. So there were some rules that we learned about determining a graph's end behavior, right? And in order to do that, we need to focus on two things on the polynomial, all right? One of them is the leading coefficient, which is a, and the other one is the leading exponent, which is n, all right? So a and n, the leading coefficient and the leading exponent, together tells us the direction of the graph's end behavior. Now, it's not the actual value that we need to know to determine that. For a, we have to look at the sign that goes with a, plus or minus, right? Is a positive value or is a negative value? And in combination, for n, we have to just look and see whether n is an odd exponent or an even exponent. All right. So given that, the rule is if n is even, whenever n is even, whenever we have an even leading exponent, the ends of the graph will point towards the same direction. The ends will point to the same direction. Now it would either point up, both ends would either point up or both ends will point down. So when n is even, okay, the graph will either open up both ends or it'll open down. How do we know whether it's going to open up or down? If a is positive and n is even, then the graph opens up. All right, so both ends will open up. Now, anything can happen in between. The graph can fall and rise a number of times in between the two endpoints, but the ends will always point up if a is positive and n is even. If A is negative and n is even, then the graph is going to open down at both the ends, right? Now, let's see what happens if n is odd. If n is odd, then one end is going to fall, the other end is going to rise. All right, so the ends are going to go in the opposite direction. Now, when A is positive and n is it's an odd exponent, then the left side is going to fall and the right side is going to rise. All right, again, the left side is going to fall, the graph is going to fall at the left end and it's going to rise at the right end. Its right end is going to rise. If A is negative and n is odd, then, and I'm going to use a different ink here, the left side is going to rise and the right side is going to fall. The left end is going to point up, the right end is going to fall. All right, it's going to go down. So given these rules, let's see how this graph would behave at its end points. Over here, A is positive, right? A equals positive 1 in this case. And it doesn't matter whether it's 1 or 2 or any number. It's the sign that matters. So A is 1 and n, which is the leading coefficient, is odd. All right. So when A is odd and, when A is positive and n is odd, we are going to have this situation here, the third one. So the graph is going to fall to the left and rise to the right. Rise to the right. So the right end is going to rise. You can also just draw a picture, all right? Show the left end falling and put a space because the graph can go up and down in between many times. So just show it like this. Okay. So that answers part A. Now question number 2 says, find the x-intercept, state whether the graph crosses the x-axis or touches the x-axis and turns around. Now keep in mind that at the x-intercept, the y values are always equal to 0. So the way we go about finding the x-intercept is make f of x, which is the same as y, equal to 0 and solve this equation for all the x values. Now it's best to first see if you can factor the polynomial and then make each factor equal to 0, use the zero factor property and come up with the values of x. That's the easiest way if it is factorable. However, this particular polynomial is not factorable. So we have to use all the different steps we learned to factor it and then come up with the x-intercepts of the function, of the equation. All right. So we start with what's called the possible rational zero theorem. The rational zero theorem. What does that theorem do? It shortlists the possible zeros, the possible x-intercepts of this function. All right. So it'll give us a handful of values which could be the zeros, which could be the x-intercepts. All right. But first we will come up with that list and then we will apply the synthetic division method to identify the actual zeros, the actual x-intercepts. All right. Now, let's start with the rational zero theorem. What does the rational zero theorem say? It is, if you remember, it's P over Q method. So it's the zeros will be in a ratio form of P over Q. Now, what is P? What is Q? P is the last term of the polynomial. So in this case, P is negative 20, right? The value of P is negative 20. Q is the leading coefficient of the polynomial. So in this case, we have 1, which is the coefficient of x cubed. So Q is positive 1. Now, in the next step, what we do is we factor negative 20. We find all the factors of negative 20 with both signs. So plus minus 1, plus minus 2, these are all factors of negative 20. Plus minus 4, plus minus 5, plus minus 10, and plus minus 20. Those are all the factors of, just let me write this down, plus minus 20. For Q, it's plus 1, so the only factors are plus minus 1. Now we have to create ratios with, with each of these factors of P over the factors of Q. All right, so it'll be plus minus 1 over plus minus 1, plus minus 2 over plus minus 1, plus minus 4 over plus minus 1, plus minus 5 over plus minus 1, and so on. So we will end up, because the denominator is 1, plus 1 or minus 1 doesn't matter, the possible rational zeros will be plus minus 1, plus minus 2, plus minus 4, plus minus 5, plus minus 10, and plus minus 20. So we have shortlisted a set of values which could be or may not be the zeros of the function, but we have to find that out using the synthetic division process. All right. So let's pick some values. We'll start with the smallest value, negative 1, as the divisor. But let's set it up in synthetic division form. How do we do that? We take all the coefficients of the polynomial. So in this case, x cubed plus 8x squared plus 11x minus 20, the coefficient of x cubed is a 1. So I'm going to write that here. Then it's 8 plus 8 for the second coefficient. The third coefficient is plus 11. And the last one is negative 20. So we have all the terms visible. There are no missing terms. Otherwise, we would have to bring that out with a 0. But here we have all the exponents are in order and visible. So x cubed, x squared, x to the 1, and the last one is x to the 0. So we have written out our coefficients. Let me put the separator here for the synthetic division, and to the left of the separator I'm going to start with negative 1, and let's perform the division. So what is the process of synthetic division? This 1, bring down the first coefficient, which is 1, and write it under the line, and then multiply 1 with negative 1. Now keep in mind that this negative 1, the divisor, is actually denoted by the letter C. All right, because eventually we are going to put this C in factor form once we find 1, once we identify 1, which gives us a remainder of 0. Okay, so let's continue with the process anyway now. So 1 times negative 1 is negative 1. So I'm going to write the negative 1 under positive 8. 8 minus 1 is 7. All right, 8 minus 1, we are adding the terms. 8 plus minus 1 is positive 7. Now do the multiplication again. 7 times negative 1 is negative 7. All right, so we have here 4, right? 11 minus 7 is a 4. 4 times negative 1 is negative 4. And negative 20 plus negative 4 is negative 24. So here we have a remainder of negative 24, not a 0. If this were a 0, then negative 1 would have been a 0 of the function. However, this negative 24, the last one, is always a remainder, right? So minus 1, let's cross that out. That is not a 0. Let's do another synthetic division, this time by plus 1. All right, so I'm going to rewrite the coefficients again. 1, positive 8, positive 11, and negative 20, and then again perform the synthetic division, but this time using plus 1. Again, same process. Draw a line under, bring down the 1 and write it under the line. 1 times 1 is 1. 8 plus 1 is 9. 9 times 1 is 9. 11 plus 9 is 20. 20 times 1 is 20. So we write a positive 20 under the negative 20, and this is a 0. So bingo, we have found a 1, 0 of this function. Therefore, plus 1 is a 0 of the function, and therefore we can use it as one of the factors of the polynomial. All right. So the way we write it is over here. It's x. Let me write it here. All right. So 1. Remember, this is c. All right. This plus 1 is c. But the form of the factor is x minus c. Remember, it's x minus c is how we factor our polynomials. X minus c1, x minus c2, x minus c3. That's factoring it at the simplest, in simplest terms. All right. So we have found one of the zeros, and we will write it as x minus plus 1. So I'm going to write it as x minus 1. All right. Even though this is a plus, the form has x minus c. Therefore, you have to make sure that it's x minus plus 1, which is x minus 1. Now, the rest of the factor here has to be composed out of the quotient of what we obtained from the synthetic division. All right, so it's going to be, we had the highest power was x cubed, so we are going to start with x squared. So x squared, 1x squared, which is the same as x squared, plus 9x plus 20. All right, so we have partially now factored our polynomial. It's x minus 1 times x squared plus 9x plus 20. However, we have to have it in x minus c1, x minus c2, x minus c3 form. All right, so we have to factor x squared plus 9x plus 20 now. All right, now x squared plus 9x plus 20 is factorable. We find factors of 20 which add up to a 9. Remember the process of factoring trinomials. So that's what I'm going to do here. X squared plus 9x plus 20. 5 times 4 is 20. Right, let me write it down here. 20, we have to find factors of 20 that that will add up to a 9. So 5 times 4 when multiplied gives us a 20, but when added gives us 9, correct? So 5 and 4, we can use those as factors. So I'm going to write here x minus 1 times x plus 5 times x plus 4 equal to 0. All right. Now we make each factor equal to 0 and solve for x. So let's do that. X minus 1 equal to 0. Therefore, x equals positive 1. X plus 5 equal to 0. Therefore, x equals negative 5. And x plus 4 equal to 0. Therefore, x equals negative 4. So the x-intercepts of our of this graph of the function are going to be the following. Let me write that with a different ink here. X-intercepts are going to be remember at the x-intercept, the y-coordinate is always going to be 0. So when we write it in ordered pairs, it has to be 1, 0, negative 5, 0, and negative 4, 0. So these are the x-intercepts. And the highest power, this is a function of degree 3, a polynomial of degree 3. And by the theorems that we learned, all right, it will have 3 x-intercepts, 3 solutions, all right. So that's why we got 3 solutions of x, and therefore 3 x-intercepts. Now the other question says, state whether the graph crosses the x-axis or touches the x-axis or turns around. All right, so it would turn around if there was a multiplicity in the x values. Or each of these values occur only once. There's no multiplicity as such. All right, they occur only once, 1, negative 5, and negative 4. So it's not going to turn around. It's going to cross the x-axis at each x-intercept, right? Let me finish up part B of this question by saying that the graph of the function will cross the x-axis at the intercepts because the x-intercepts are all of multiplicity 1. All the zeros of the function are of multiplicity 1. So I'm going to write that down here for you. The graph of the function will cross the x-axis at the intercepts as the zeros of the function, or you can say as all the zeros of the function are of multiplicity 1. Are of multiplicity 1. Okay. Now part C says find the y-intercept. Finding the y-intercept is pretty easy. All we have to do, again, remember that at the y-intercept, the x coordinates are 0. So all we have to do is we have to plug in 0 for x and evaluate the expression, which is x cubed plus 8x x squared. 8x squared plus 11x minus 20, correct? That was it, I think. X cubed plus 8x squared plus 11x minus 20. We just have to plug in 0 wherever there's an x and do the evaluation. So we will have f of 0 equals 0 cubed plus 8 times 0 squared plus 11 times 0 minus 20, which is going to be equal to minus 20. So the y-intercept is going to be at 0, negative 20. All right, so let me write that down. Y-intercept is at 0, negative 20. At the y-intercept, the x coordinate is a 0. Now part D of the question says determine whether the graph has y-axis symmetry, origin symmetry, or neither. So to determine the symmetry, the way we go about it is we take the original function and we replace the x with the negative x and we evaluate the function. And then if it has y-axis symmetry, then the resulting function will be the same as the original function. So let's go ahead and replace x with negative x and evaluate the function first. So we are trying to determine the y-axis symmetry, all right, to start with. So I'm going to replace x with negative x wherever there is an x in the function. So plus 8 times negative x whole squared plus 11 times negative x minus 20. So the resulting function is minus x whole cube is minus x cube plus 8 times negative x whole squared is positive 8x squared. Whenever we raise a negative value or a negative expression to an even power, we always get a positive result. And then plus 11 times minus x is minus 11x. And then the last one is minus 20. So now let's see how the function, or whether the function has changed or not from the original function. So here was our original function. We see we got minus x cubed. The original was x cubed. Then we have a plus 8x squared. So we don't even have to go through the other terms. The first one itself has changed. So that means it's a different function now. All right. So we conclude that there's no symmetry about the y-axis. Why? Because it's not the same function. Not same as original function. So no y-axis symmetry. So no y-axis symmetry. Okay. The other one is symmetry about the origin. In order for a graph to be symmetrical about the origin, what must happen is when we replace x with negative x, all the signs must have changed from the original function. So let's see what happened here. The first one was a plus x cubed. In the resulting function, the first term is now a negative, so there was a sign change here. For the second term, there was a plus 8x squared. In the second term, in the resulting function, it's plus 8x squared. So no sign change from the original function. Therefore, this does not have symmetry about the origin either. In order for the symmetry to be about the origin, all the signs, every sign, all the terms must have a sign change from the original function. That's not the case here. So no symmetry about the origin. Therefore, the only option is that it's neither a y-axis symmetry nor there is a symmetry about origin. So answer is neither y-axis nor symmetry about the origin. Complete this question now. The last part is to sketch the graph of the function with the information we have found so far. So I've listed the information here. The x-intercepts that we found are -5, -4, and at x equals 1. The y-intercept as an ordered pair is 0, -20. And we know the behavior of the graph at its endpoints, which is it will fall to the left and rise to the right. All right. Now we need to find a few other points before we can complete the sketching of the graph. But let's just plot the points of the x-intercept and the y-intercept so far. So minus 5 comma 5 would be this point here. Sorry, minus 5 comma 0. This is the x-intercept, the y-coordinate will be 0. So minus 5 comma 0 will be right here. The other x-intercept is at minus 4 comma 0, which is this point here. And then 1 comma 0 is the third x-intercept, which is right here. All right. The y-intercept is at 0 comma negative 20. Now this graph goes only till negative 11, so I have to extend the y-axis a little further down and just say, let's say we have negative 20 somewhere here. Okay. Therefore, our y-intercept will be located here, 0 comma negative 20. So we have plotted our x-intercepts and our y-intercepts. Now we have to find maybe a couple of other points between the x-intercepts, all right? So we have here between minus 5 and minus 4, I think the easiest value to choose is maybe right between the two, so negative 4.5. So I did some calculation here. So we will need to plug in negative 4.5 into the function and evaluate it. And when I did that, I got 1.375 for the y value. So I'm going to plot that point when x is negative 4.5. The y value is 1.375, which should be a little above the positive 1 on the y-axis. So I'm going to mark it here, right? And another point between negative 4 and positive 1, I have chosen negative 1, and when I evaluated the function using negative 1, negative 1 is an easy value to choose. So when you have to choose a value to evaluate the function, then make it easy for yourself. All right, 1, negative 1, these are easy for calculations. All right, so that's why I chose negative 1. And when I did the calculation, I got negative 1 plus 8 is 7, 7 minus 11 is minus 4, minus 4 minus 20 is minus 24. So when x is negative 1, y is negative 24. That means I have to pull down the y-axis a little further down. Let's say here is negative 24. So at negative 1, it'll be somewhere here. All right. So I think we got enough points now to be able to sketch the graph. So we'll start from the x-intercept at negative 5, then go up to negative 4.5, then come down, and then go all the way to negative 24, and then go up, cross the y-intercept, and go all the way up to the x-intercept of 1 and extend the graph all the way to infinity. Remember, the direction says fall to the left and rise to the right. So it's going to rise all the way to infinity to the right, and on the left end it's going to drop all the way to negative infinity on the left hand side as the left end behavior of the graph. So that completes, this is a complete sketch of the graph as best we can do. by hand using the information we found while answering the questions of the different parts of the question.